Hello everyone, welcome to the Spintangle. Today, this is the lecture 11 and the second lecture of microcanonical ensemble. Okay, microcanonical ensemble. In this lecture, we will be discussing on the various parameters. Mainly, this lecture is completely focused on the parameters of thermodynamics. Okay, this is what we called a microcanonical ensemble, a detailed study. Okay, a mathematical study here. To do this thing, first of all, let me write two important formulas. Okay, two most important formulas. These two formulas are written as formula 1. Say this is formula 1 I am writing here. This is TdS is equals to dq. You can write this thing as dq also is equals to du plus pdv. This is up to this thing. This is first law of thermodynamics. You know this thing, okay? And this comes from the TdS equation, and another extra term minus mu dn. This is the third term. You have to remember this thing. Okay, this is the formula 1, and the second formula is given by G is equals to U plus PV minus TS. Okay, this is the second formula you have to remember. Okay, this is the free energy formula. This is the free energy formula. I am writing this as energy formula. Okay, these are all free energies. Okay, and this is the say this is the mixed kind of formula. Okay, mixed formula. This is formula 1. This is formula 2. You have to remember these two things to solve each and every kind of problem related to microcanonical ensemble or any kind of statistical problems which are statistical and also thermodynamical problem. These two formulas come from thermodynamics. Okay, this is completely coming from thermodynamics. Okay, so let's start. We know in microcanonical ensemble, the leading variable is entropy. Entropy is given by S is equals to K ln omega. This is what we call the entropy. Here, as in this ensemble, omega equals to in this ensemble, the constant parameters are n, v and e, because in microcanonical ensemble you know the constant parameters are n, v and e. Therefore, this omega will be function of n, v and e, and hence s will be function of this means entropy will be function of also n, v, e. This is the first thing you need to know about. In some book it is written as this E is replaced by U. This is the internal energy. Okay, this is energy here, This is E for energy here, and U for what is this? Internal energy. This means you may substitute this formula as S is equal to S N V U. Okay. So what we have to find here, we have to find in this lecture, we have to find some important parameters. Okay, which are these? Say CV, CP, and CP means gamma. Gamma equals to what? CP upon CV. Okay, therefore it becomes P, pressure, temperature, the chemical potential, internal energy, enthalpy, Helmholtz free energy, and Gibbs free energy, and so on. Okay, this extended lecture will be discussing on these parameters, how to obtain these parameters from the formula given above. Okay, first of all, let us the easiest one I am taking first. Say, make an heading on temperature, how to find temperature from this formula. Temperature, just wait. We have our first formula as TdS equals to dq equals to du plus pdv minus mu dn. Okay, so this formula is written in this format, that I am taking only TdS equals to du plus pdv minus mu dn. Therefore I am not differentiating this thing. If n and v, that the number of particles and the volume of the system is n and v are constants, that means what? Dn will be what? 0, and also dv will be what? 0. Therefore from this formula what we get? TdS, I am writing this as follows. TdS equals to, say this is what will happen here, du plus 0 minus 0. Therefore T will become du upon ds at constant n and v. Okay, you can write this constant. Only writing n and v will do its work. Okay, we are not gonna write this thing like this. Okay, therefore we have to change this thing. We can write it as 1 upon ds by du at n comma v constant. This is n comma v. This is the formula of temperature. That means temperature becomes what? That means the temperature becomes T equals to 1 upon ds by du n comma v. This is the formula of temperature in case of microcanonical ensemble. Okay, sorry, this is microcanonical ensemble. Okay, this is microcanonical ensemble. Okay, so going to the next part, say make an heading on pressure. Okay, make an heading on pressure. We do this thing. What is pressure? How to find pressure? You can write this thing. Say we have again our special formula. What is this? TdS equals to du plus pdv minus mu dn. If number of particles and internal energy remains constant, number of particles and u remains constant, That means dn becomes what? 0. du becomes what? 0. Okay, therefore from the above formula, okay, what we can write, tds equals to, only it remains pdv. Therefore p becomes what? Pressure. This is pressure. P becomes t ds by dp. This is the standard form of pressure. You may write, you may replace the value of T from the above mentioned formula of temperature. Okay, you can put this formula here. Okay, where it is good. Okay, wait for a while. Okay. What you can write here? Okay, you have to write this thing here, n comma u, because by taking n and u constant, you have got this. Okay, therefore it becomes ds by dv at n comma u upon the value of t is 1 upon ds by, this is ds by dv. Okay, here ds by du at n comma b. I think I'm correct. Okay. This is the answer of pressure. This means pressure becomes what? Pressure becomes ds by dv at n comma u and ds by du at n comma v. You just have to remember the formula 1. You will be getting these things automatically. Okay, you have to remember this formula, that tds is equals to du plus pdv minus mu dn. Whatever you want to figure out, you can do it from this formula. Okay, now to find the technique is that to find, I'm telling you the technique, how I am doing this thing. I have you have got this point. Okay, I think so. Next, for how to find the chemical potential. What is chemical potential here? We have our formula that TDS is equals to du plus mu d, du plus pdv minus mu dn. In case of you are finding chemical potential, I'm just doing the systematic procedure. What I am doing in my mind, okay, is the chemical potential. You have to make survive this term. To make survive this term, you have to make constant this term. Okay, this is constant, and this also has to be constant. Therefore, they will vanish. They will not survive, and it is also not survive. It will survive. Okay, and the third term will survive. From the third term, you can easily find what is mu. Therefore, what I can do from this, in this case, taking internal energy and volume constant. That means du will be what? 0. dv will be what? 0. That means what we can conclude this formula from this formula, TDS equals to minus mu dn. Okay, therefore mu will become minus t ds upon dn. The value of t, we can put this thing. Okay, this is at u and v constant, u comma v. This means what? ds upon dn at u comma v. Also in the denominator, the value of temperature, what is that? 1 upon ds by du. I think this is correct. N comma v. This is the formula of chemical potential in case of microcanonical ensemble. Okay, why entropy is called the leading variable? You may see this thing, that in each and every formula we are differentiating this entropy. Okay, each and every time we are differentiating entropy. In this formula also we are differentiating entropy with respect to something. In this formula also, this is why the entropy is called the leading parameter. By differentiating entropy, we are getting our result. Okay, so the mu becomes what? Mu equals to minus ds upon dn at u comma v, and in the denominator ds upon du at n comma v. I think this is the answer. Okay, what is the internal energy here? Can you find internal energy here? No, you cannot find internal energy here. Why? Because internal energy is constant here. Okay, in this formula you cannot obtain internal energy. So next thing is what? Next point, how to find enthalpy. How to find enthalpy? Nowhere it's been given the formula for entropy. What is our formula? du plus pdv minus mu dn. Nowhere it's been the enthalpy. Therefore, what you have to do here? You have to drag the second formula which I have given, that is G equals to U plus PV minus PS. Also, please correct one thing, that G is equals to U plus PV minus PS. This also equals to mu n. Okay, you have to write this thing on the very initial of the formula. Okay, I have written on this formula also. This equals to mu n. This equals to mu n. We have to correct this thing. Okay. Sorry, mistakenly done. I'm extremely sorry. Okay. This is the first formula, this is the second formula. Now you can obtain the enthalpy from this thing. What is enthalpy? Enthalpy is this thing. U plus PV is called enthalpy. Okay, written as H. H is what? Enthalpy. Enthalpy is written as U. H is equals to U plus PV. Therefore, you may write this thing. G is equals to H minus. Sorry. Enthalpy is U plus PV. Okay. Therefore, you have to write this thing. H is equals to U plus PV. Okay. U plus PV. Okay. Now putting U plus, let the V remains here, and the value of P was what? Was P? Del S by del V at fixed n comma U, and del S by del U at n comma V. This is the formula. This is the answer. This is the answer for enthalpy for microcanonical ensemble. Okay. Now you have to find the Helmholtz free energy. Helmholtz free energy. What is Helmholtz free energy? We have the second formula, that G is equals to what is G is equals to U plus PV minus TS. Okay. In this formula, this is called U minus TS term is called U minus TS term. This is called Helmholtz free energy. It is given as A. In some book, I think it is written as F. Okay. This is A. This is called Helmholtz free energy. What you can mention from this? Okay. A is equals to U minus. You know the formula of T. What is the formula? 1 by ds by du at n comma v. This is the formula of A. I think this is correct. Okay. Helmholtz free energy. How to find Gibbs energy? Now the point is Gibbs energy, Gibbs free energy. Let me change the ink. How to find? We know one thing, that the entire formula of this thing was G is equals to U plus PV minus TS equals to mu n. Therefore, you can conclude this thing. You can write this thing, G is equals to mu n easily. You know what is mu here? Mu was minus ds upon dn at constant v comma u and ds upon du at constant n comma v. I think this is correct. This is the formula of G, or Gibbs free energy. Okay, now let's find the CPCV. Okay, find the CPCV. How to find CV? CV is the next point. How to find CV? To find CV, we need to know about what is CV here. Okay, we know CV is equals to dq by dt at n comma v. This is why from the definition we know CV is called the heat required to increase the temperature by 1 degree centigrade of 1 degree 1 degree centigrade of 1 kg mass is called at constant volume at constant volume. Also, you can see this also, n will be constant there. Okay, because if n increases, the volume will automatically increase. Okay, 1 kg of mass at constant volume is called CV. Okay, I have written it. Okay. Therefore, from this definition, you can see that CV becomes this. Okay. Okay, and I think m comes here. Okay, and m becomes 1, and the formula becomes this. This is the formula of CV. Okay. Now, what you have to do? We know dq is equals to the TDS equals to dq is equals to du plus pdv minus dn. Okay, this means take this thing only. For here, what are the constants? N and v constants. For n v constant, what becomes? This term vanishes. This term also vanishes. This means dq becomes what? This means dq becomes du. Therefore, from CV will be what? CV was given that dq by dt, at n comma v is equals to du by dt at n comma v. This is the required formula for CV. Now, going to the next point called CP. Okay, let me take another ink. Say it is Cp. How to calculate Cp? Cp is what? Cp in the similar way, Cp is written as dq by dt at p comma n. P comma n. Okay. So going back to the formula again, that dq is equals to, we know everything. Actually, we don't know anything. dq is equals to du plus p dv minus mu dn. P and n are constants. This means what happens here? If n constant, this term goes out. Therefore, dq at p and n constant becomes du plus p dv. Okay. Therefore, Cp will become, put this dq in this place. What does it become? du plus p dv by dt at pressure and number of particles are constant. Okay, this is Cp. Now, what we can do from this thing? We are introducing another term, VdP, for our simplicity purpose. Okay, VdP. VdP is 0 actually. Why 0? Because pressure is constant. Because pressure is constant. Therefore, VdP is equals to what? 0. That means you are adding a 0 with this term. Okay, I am writing this. I can write Cp du plus pdv plus vdp by dt at p comma n. This is n. Sorry, this is n. Why this is 0? This is actually 0. Just adding 0 with something will remain unchanged. Okay, that means what becomes here? This becomes, you can write this thing as say, we know I am giving this a number. Okay, say this is number 1 equation. We know enthalpy is what? H is equals to u plus, wait, u plus pp. Therefore, taking differentiating this h, what we will get? Du plus, here is a uv term of differentiating, partial differentiation. This means pdv plus vdp. From this, what you can write? That pdv plus vdp equals dh minus du. Okay, what is this du here? Du will become 0. Why du 0? Because in case of microcanonical ensemble, the energy is constant. In the pair, NVE is constant. Okay, this E may be written as U. Okay, in microcanonical ensemble, why it is 0? For microcanonical. Okay, that means PdV plus VdP becomes what? PdV plus VdP becomes dH. Okay, these things, therefore equation 1 becomes, I think this Cp equals to du, sorry, this du also becomes 0. This becomes dH by dt at p comma n. Okay, where it becomes, I am writing this thing here, u is equals to constant, capital U is equals to constant for microcanonical ensemble. This means del u becomes 0 in this case. Okay, okay, this is the formula of Cp here. This is the formula of Cp. Therefore, what gamma becomes, giving another point, say this is gamma. Gamma becomes what? Gamma is what? Gamma is equals to Cp by Cv. what was CP in our case? Put the CP, put the value of CP here. So what is CP? CP dH by dt at p comma n constant. Okay, and what was our CV? Our CV was du by dt at n comma v at n comma v. This is the value of gamma here. Okay, I think I am correct. Okay, now this thing is over. Okay, let me end this video on this topic and uh, on this thing, and I'll be discussing on classical ideal gas in microcanonical ensemble in the next class. Okay, so up to this, thank you for staying with us, and these are all mathematical terms, and you do not have to remember each and every term. Just practice these things and you will be able to do each and every time whenever you are requiring. Okay, so thank you, thanks a lot, share and subscribe.